component diagrams, one way to show required and provided interfaces is to use the assembly connectors and the lollipop or ball and cup notation described in the previous movie. In this movie, we'll learn another way to show the relationships between components and interfaces. And this other way is to borrow the realization and dependency arrows from class diagrams. As you'll see in a minute, to use this notation, use UML stereotypes to show clearly which elements are interfaces and which are components. In this diagram, you see we have two components, pet and licensing agency. The pet component has two interfaces. It realizes the animal interface, and it requires the license interface. And in turn, the license interface is realized by the licensing agency component. So using these assembly connectors and the sort of lollipop and cup notation, you can see that each of these components has relation to the various kinds of interfaces. Now, using dependency and realization arrows, we can show the same information. So let's move this up here. And so we have a component called pet and another component called licensing agency. And for these two components to interact, we need the license interface. And instead of showing it using this notation, we're going to show it as a class with the interface stereotype. And you can see that here. There's also another interface, the animal interface, and we'll show that one in the same way. So now we have our components and our interfaces, and we have to show the relations between them. We'll do this using the realization and the dependency arrows that you saw way back when you were working with class diagrams. The pet component realizes or implements the animal interface. So we want to use a realization arrow, like so. Similarly, the licensing agency component realizes the license interface, so we'll use the same kind of link between those two elements. Now the pet component depends on the license interface, so we'll use the dependency arrow. That's a dashed line with an open arrowhead. So now these two different notation styles give the same information. We have the pet component realizing or implementing the animal interface, and to show that we use this realization arrow, which is a dashed line arrow with a triangular arrowhead, and we have the same relationship between the licensing agency and the license interface. The pet component requires or depends on the license interface, so we use the dependency arrow. So you can see how these two styles give the same information. This is more compact, but this perhaps gives more information. Let's look at another example that shows how that might work. In this example, again, we have two components, order and product, and we have an interface called product lookup. As you can see, this interface is realized or implemented by the product component, and the order component depends on or requires the product lookup interface. But using this notation, we're able to add some extra information. We have an operation that belongs to the product lookup interface. So if you need to include this kind of information in your diagram, then this is the better style to use. Now, whenever you have an order, you don't just have a product, you also have a customer. So let's look at how that might relate. Let's move this over here. So let's create a component called customer. And in order for the customer and the order components to interact, we're going to need an interface. And let's call that the customer lookup. We'll make that an interface. In this notation style, you have to add the keyword that shows the stereotype for the interface. So again, the order component is going to depend on this interface, which in turn is realized or implemented by this component. So to show that, we'll draw a dependency arrow. The order depends on the customer lookup interface, and we'll draw a realization arrow. The customer component realizes or implements the customer lookup interface. And again, you can add operations in this classifier to give a higher level of detail if that's what you want to show in your diagram. So using realization and dependency arrows can be useful when you want to show the interface's operations inside your diagram. And this notation style also lets you attach other elements to an interface. For example, if a component implements a protocol, you can link the appropriate interface to a protocol state machine. And these are discussed in another movie. If you don't need to show the operations the interface implements, or if you don't need to link to an element such as a state machine, then using the ball and cup notation is less cluttered, easier to get the big picture quickly. So as always, the notation style that you use is going to depend on your audience and what you're trying to show in your diagram.